Ladies and gents, hello again. This is Chapter 4. We're going to start with factoring. If you are a member of one of the classrooms of the teachers in the situation the video is taking place with, you know who you are. This will be day 1 in your booklet. As you know, I am Mr. Benjamin. Weird looking smiley face, but you know, that's me. This is grade 10 math, but anyone who's looking for factoring intro or instructions is good to watch this, and the date is April 6th, 2020. We're going to be considering two things here: the greatest common factor of binomials and trinomials, and then factoring by grouping as well for those same values. Learning goals. We're going to start off with defining our key terms. There's quite a few. I feel like that purple's too dark, so I'm going to go with something lighter. Let's try green. So that'll be on our next slide. Then we're going to fully factor monomials. It's hard for me to say. Mono being the key part there. Mono meaning 1. We're going to fully factor binomials. Bi meaning 2. And then finally we're going to factor by grouping. Now odds are you've already done something like this, but it's good to apply labels to things so we can keep in mind when we're answering questions. For example, when we're expanding, what does that term expand mean and what does factor actually mean? So it's good to know what we're talking about. Starting off with our key terms, you're going to want to keep in mind this image and kind of follow along with this image as we define things. So, greatest common factor, also known as GCF for short. The greatest number and or variable that is a factor of 2 or more numbers or terms. If that didn't make sense, if one of those terms was kind of new to you, I'm going to define the two terms here, coefficient and variable, but if this doesn't make sense now, it'll make sense by the end of the video. A coefficient is a value placed before a variable in an expression. This generally means multiplication. So 4x, that would mean 4 multiplied by whatever x is. Okay? If you look at this image here, like I said, the coefficient is our 4. The variable, which I'm about to define, is our x. And then the 7 is a constant. You don't need to worry about that. I'll write in constant here. Constant. So variable is a quantity that can change. That's literally what the term variable means. In mathematical terms, it is represented by a letter, so x, y, z. So again, in our example, this variable is x. The coefficient, circle coefficient in blue, was 4. Continuing on with key terms, we have monomial. Mono, as I said, means 1. Let's write that in blue. So, it's an algebraic expression consisting of one term. Okay, so in this case, 3x minus 7. This is one term, because it's in brackets. A binomial, keyword being bi. Bi means 2. 2. So an expression containing 2 terms. So 4x subtract 3 and 6x subtract 3 as well. These 2 terms are being added together, therefore this is a binomial. Forgive me if the hand is in the way of that, but I'm saying it as I'm underlining it, binomial. You can look at this image up here to get an idea. This is monomial, 1 term, negative 2x to the power 5. Binomial, 2 terms, x plus 5. Trinomial, 3 terms. Polynomial, more terms than that. Keeping in mind, the last thing we're going to kind of define is expanding versus factoring. If I take this term here, coefficient of 2, coefficient, we have a variable y, and we have a constant here. Okay, I'm going to write it out again, just give me some more space here. 2 bracket y plus 3. If I were to expand this, that means multiply it out. So I'm going to put multiply here. What I would end up with is 2y plus 6, because I'm distributing the 2 into the positive 3 and the y, and I'm multiplying it each time. If I were to factor it, now that's going backwards. Factoring you can kind of say is the same as dividing, which isn't fully true in all statements or in all aspects of the word, but you can make that claim when you're looking at this image. So if I were to factor this, I'm going to divide both of these terms by 2. 2y subtract by 2, well, it's actually 1, but I know I can take it out. So I can pull the 2 out there, so that's why the 2 is there. And 6 divided by 2 is 3. So that's there. Looks cleaner that way, so I'm just going to clear that up. If we want to factor monomials, so looking at this first example, I have to consider factoring, keeping in mind, factoring is division. I'm going to write up here, divide. I have 2m squared and negative 18m. I have to think about what value can go into 18 and 2. Okay, 1 can go into everything. 2 can go into 2, can also go into 18. There's nothing higher than 2 that can go into 2, right? 3 can't, 4 can't, 5 can't, 6 can't, none of those. 3 can go into 18, that's okay. 6 can go into 18, that's okay. But none of those can go into 2. So I'm going to erase all of that. And I know I can pull 2 out of this first value. So I'm going to put a bracket there. I'm left with m squared subtract. If I take 2 out of 18, divided by 2 equals 9. I have 9, and I still have m. Now if I look at this, I still have m squared here, and I still have m here. I could take 1m out. Take 1m out. So I'm open brackets factor. So I'm going to make that equal sign there. Make this equal to 2m bracket m subtract 9. So that is my final answer. Now if I wanted to check this, I could always expand. So if I expand 2m multiplied by m, I would get 2m squared. 2m multiplied by negative 9, I would get negative 18m. So this answer is the same as my original question. So that's correct. Looking at this second example here, let me just draw that out. I'm going to go with the same approach. I'm going to look at my first value. I have negative 3x to the power of 5. Then I have 18x cubed. What can I take out of both of these terms? I can take a 3 out for sure. Take out a 3 here, take out a 3 here, I'd be left with 6. So it's 18 divided by 3 equals 6. Get rid of all that. So I'm going to write this in yellow. Let's write it in blue instead. Equals 3. Whoops. If I take the 3 out there, I'm left with negative x to the power of 5 plus. If I take the 3 out there, it'd be 6. Again, that's dividing. X cubed. If I look at this, can I still take values out? Okay, I've got x to the power of 5 and x to the power of 3. I can fully take out x to the power of 3. I'd be left with x squared on this side. So equal negative x squared plus 6. And still looking at this, I can take out that negative to make it look a bit cleaner. And the one thing I forgot to do, I'm just going to erase that. I forgot to put the x to the power of 3. 3x to the power of 3. Now if I do this once more, I can take out that negative value. Negative 3x cubed. Hope I'm not covering up my mic there, excuse me. Plus x squared minus 6. And that positive can actually go away because this is all being multiplied. I think that's all I can take out from here. Now if I wanted to check that, I could expand it. And again, I'm sorry if the hand is here blocking the view, but if I multiply these terms, I would end up with negative 3x to the power of 5 plus 18x to the power of 3. So that checks out as well. Okay, this is getting a bit heavier in terms of values, variables. I see I have 2 variables here. variables x and y. I've got squared, 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 cubed. I've got value, value. Let me actually circle these in a different color. So I have 8, 6, and 4. So the first step I'm going to do is find out what goes into 8, 6, and 4. Okay, going into my 4, I know 4 can go in there, but 4 can't go into 6. 4 can go into 8. So it's not going to be 4. What else can go into 4? 2. 2 can go into 6, 2 can go into 8. So that looks good. So, equals. If I pull out a 2 completely, I'll be left with 4x cubed, subtract 3x squared y squared plus 2x squared y. Now all I did was take a 2 out from each term, from each value. I still have x cubed here, I still have x squared here, I still have x squared here, so I can take out x squared as well. Equals 2x squared, bracket, 4x, subtract 3y squared plus 2y. So all I did there was take out x squared. Looks like take out x squared. And another way of saying that is factor. So I factored out x squared. Now, looking at my values, 4x, 3y squared, it should be 2y squared, I believe. Yeah, pretty sure it should be 2y squared. Oh, no, unless I did it wrong completely. No, okay. Ignore me. Ignore that last 10 seconds. I don't think I can factor anything else out of here, so this should be my final answer. Now I can always expand to check. Now expand means distributing this value, multiplying it each time. So I would have 8x cubed, subtract 6x squared y squared, plus 4x squared y squared. So I think I did actually make a mistake with that y squared, so that shouldn't be there. And that's it. We're good. Binomials, remember this is 2 terms. As you can see here, we have one term here added to another term there. We actually have 2 ways of looking at this, or 2 ways of doing it. You will notice that 2y plus or minus 1, 2y subtract 1 I should say, is common in both terms. So I could literally just pull that out and end up with 2y subtract 1 multiplied by 3x plus 4x. And realistically, that could be my final answer. I could look at it just like that. Another way of doing it is taking that common term, that 2y subtract 1, and assigning a variable to it. So here I'm saying let 2y subtract 1 equal x. So if I rewrite it, I'd end up with 3x multiplied by x plus 4x multiplied by x. I'm actually going to change my x to a y because I don't want to confuse myself, which happens quite often if we're honest with ourselves. But that's okay. We're all learning together. So I've got 3xy plus 4xy, and I know I can pull out that y. So factor y. So I'd end up with y being multiplied by 3x plus 4x. And we did say let y equal, or let 2y subtract y equal y. So we're going to put that back in here. So 2y subtract 1 multiplied by 3x plus 4x. And this answer is, at least it should be, the same as this answer. Okay, same idea, different values, different example. Let's start off with the let statement. So let 3z subtract 4, which is what we have in both groups, equal x. So if we rewrite that, it'll be 8y multiplied by x subtract x. I actually don't need these brackets here either. It'll make it easier. Oh, I erased the whole thing. Let's write that again. Make it easier to see that I can really just pull out both of these x's. So I'd have x multiplied by 8y subtract 1. Now, since we said x was equal to 3z minus 4, I'm going to write that out again. 3z minus 4 multiplied by 8y subtract 1. So that is our final answer. I forgot my equal signs here. I'm going to write them in. So if I wanted to ignore the let statement and just write it out differently, or sorry, in the same way but with a different approach, I can literally just factor out these two values. So 3z subtract 4 would be multiplied by 8y subtract 1. And again, if we wanted to distribute, we could, and we'd end up with the exact same value, same answer. Really hope my z's do look like z's. Z. Z. I hope that works out. Factoring by grouping is the last approach we're going to take. This example is a little strange because it has nothing but variables. There's no values, there's no coefficients. But what we can do is kind of say we can treat each variable as a coefficient. That doesn't really make much sense when you hear it, but if I look at this first group, I see it's AC plus BC. The second group, I have AD plus BD. So I have something common amongst each one. So I can take C and multiply it by A plus B and add D multiplied by A plus B. So this looks a bit easier to kind of work through. Now again, we can do this two ways. I can say let A plus B equal X, for example. If I were to rewrite that, I'd have C multiplied by X plus D multiplied by X. Okay? If I'm looking at the values here, I can see that X is common between both of them. So I can have X multiplied by C plus D. And that X, we said, represents A plus B. So this all equals A plus B multiplied by C plus D. And if I take this same value, bring it over here, I'll rewrite it. C multiplied by A plus B plus D multiplied by A plus B. We can see that the A plus B is common to both, so we can just factor that out. So A plus B multiplied by C plus D. And again, I've forgotten my equal sign, so let me just rewrite that. A plus B multiplied by C plus D. And that's it. Now, if we really wanted to, we could FOIL this and find our same answer. In fact, we should probably do that. Yeah, let's do that out. Okay, so FOIL. If we remember, that's first inside, or first outside, inside, last. So first values, AC plus outside, AD plus BC plus last BD. If we look at this, it should be the same as this here. Maybe it's just rearranged. I got BD, AD and BC have just been switched, but it's still the exact same function. Okay, we have something slightly more complicated. Now we've got multiple variables and values, and one of them's even squared. First thing I'm going to do is rearrange this to make it look a bit simpler. I'm going to actually just collect like terms. Collect like terms. So 2m squared plus 4m, because I have an m value here and an m value here, or an m variable I should say, plus 6n plus 3mn. Now if I look at both of these, I have an m common in this side and I have an n common in this side. So what can I pull out of this first set of numbers? Okay, I know 2 can go into 2, 2 can go into 4, m can come out and m can come out. So I can pull out 2m. So equals 2m, and what I'd be left with in this first term is just m, plus 2, because I took out a 2 there as well. If I look at the second value, what can I take out? I can take out n here, 3, I can take a 3 out from each side. So 3n. And what am I left with? N no. It's 2 plus m. Yep. M plus 2, 2 plus m, exact same thing, so I can rearrange that. 2m multiplied by m plus 2 plus 3n multiplied by, whoops, whole point was to write it out, m plus 2. So now I say I have m plus 2 here, m plus 2 here. I can factor that whole thing out. Factor m plus 2. So I'll be left with m plus 2, all multiplied by 2m plus 3n. Now if we really wanted to, we could go back and FOIL this out. Let me use a different color for that. So that would be 2m squared plus first outside 3m, oh, use a different color for that one. 3mn, first outside inside, plus 4m, and last we'll do in white, plus 6n. And this should be the same as that. 2m squared is there, 3mn, 4m, 6n. We're good. Happy face. Okay, last example. I think last example. Yep. And this one is a bit different because I have x subtract 2 and 2 subtract x, which are not the same thing. It does not equal 2 subtract x, okay? And you can prove that mathematically with values, but I'm not going to do that. All I'm going to do is rearrange so that they are the same thing. So I'm going to write this out again. X bracket x subtract 2 plus 3. Now this portion here, I'm going to rewrite it as negative x plus 2. So 2 subtract x does in fact equal negative x plus 2. That is the same, so I can do that. Okay. Now what I'm left with here, x plus 2, x subtract 2, if I factor out a negative, I should end up with the same value. Okay, what am I going to look at here? So I should still have x subtract 2. If I'm going to factor out a negative, that's going to affect my positive here, this negative, and that positive as well. So it should be negative 3 bracket x minus 2. Forgot that bracket there. So now when I look at it, I have x subtract 2, I have x subtract 2, so I can factor out x subtract 2. Factor out x subtract 2. So what will that look like? X subtract 2. So that's that part there, and all I'm left with is x subtract 3. So that should be my final answer. Green looks pretty good on black, I think. Thank you. Hope everyone's doing well. Hope that made sense. Have a great day.